Hello everyone, welcome back. Today in this video we're going to be talking about Newton's laws of motion. Newton's laws of motion. And as many of you may know, there are three of them. So the first one states an object and rest or uniform, this is our keyword, uniform motion will remain or continue the same, will be the same unless acted by an external force. Alright, law number 2 tells us, pretty much summarizes the sum of the forces acting on the object. This is sigma, sum of the forces acting on the object equals to ma. The force are vectors, the a is vector as well. 3, it tells you that all forces occur in equal and opposite directions. Alright, now you may be asking or wondering, yeah, cool, I read that on my textbook. What does it mean? Like, can you help me out? Yeah, of course. Now I'm going to give you some examples. So, very quick. Example number 1. Alright, so I would say space, but a lot of us have a hard time visualizing what space may look like in a collision or something like that in a space. So the closest to being only frictionless, which we'll talk later in this chapter about friction, an object on ice. Have you ever been ice skating and then you just have a block or something and then it's just sitting there unless it's at an incline or something, but then when you push it, you give it an initial force until you give it the force, then it starts moving. Before, it was just sitting there. So that's what the first law says. If it's at rest, it will stay at rest until an additional force is applied, or if it's moving at a uniform motion, it will not stop or accelerate until another force is applied. And if you've noticed, if you push something on ice or you slide a ice cube, it would just, on a very surface with not a lot of friction, it would just go by and it seems like it doesn't stop. That's what it means. It would just keep moving. The second part, it would just keep moving if it's moving until it never stops. That's why satellites can go around our space, Earth, which is a little bit more difficult, but you can think about it that way as well. Number 2. So force equals ma. That's just the formula. Sum of the forces equals mass times acceleration. In this case, there's only one force, so if we wanted to find the acceleration of this object, we would have to know the mass and then just divide the force that we applied over the mass. That will give you the acceleration. And last, number 3, all forces occur in equal and opposite directions. Well, have you ever been in, again, I'm going to say ice skating, and I probably should have switched to a color that actually represents ice somewhat here as well, ice. So have you ever been ice skating and you're here, then you're messing around with your friend like, oh yeah, you don't know how to ice skate, or both of you are pretty good or something, and then you decide to push him. You're like, fly away, my friend. And then this guy's like panicking, oh yeah, no, help me, right? So then you have a force that you applied on them, but if you've noticed, you also start moving backwards, right? Because the force is the same, right? So the force that you applied on him, you're applying to your own self, and you start moving backwards. Now, you may be wondering, yeah, I push my kid or my nephew, and they go faster than I do, or I don't even move. It's because, again, here, notice from equation 2, the acceleration, the speed that you'll pick up, depends on the mass. So if your kid is 3 times lighter than you, then the acceleration will be 3 times greater for him than for you. That's why. All right, guys. This is all I have for you in this video. Remember to like us on Facebook and subscribe on YouTube, and leave us some comments below. What you think, what you want to hear from us, what you want explained. Good luck in your studies.